Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's up, automotive world? This is the Automotive Diagnostic Podcast. My name is Sean Tipping. I will be your host today. Thank you so much for tuning in. I hope you're ready for a good one today. Today, we're going to be talking about oxygen sensors and how they really operate. Specifically narrowband oxygen sensors, but heck, to understand wideband sensors, you kind of have to understand how narrowband sensors work. You got to learn to crawl before you can run. And it's actually a more complex sensor than you think. Kind of a unique sensor on the vehicle. And we still see narrowband sensors in a lot of vehicles today, whether it be upstream, downstream of the catalytic converter, or both. Even on modern vehicles, they're still out there, even though widebands have taken over. Joining me today to help me explain how these sensors actually work is John Gillespie. And John is a CTI instructor. He is a shop owner, and he's just an overall wealth of knowledge. So I feel very excited to have him on the podcast here today to help me illustrate how these sensors really, truly work. Because for a long, long time, most of my actual technician career, I didn't really understand how these sensors worked, what they were actually doing. Does that mean I couldn't diagnose and fix them? I figured it out, but I think as technicians, I think as diagnosticians, we really crave understanding how a sensor works, how any component works. We want to know all the intricate details. And in certain situations, understanding that, having that knowledge is actually going to help us fix the vehicle, make the right call, diagnose the problem. So with that being said, I'd like to welcome John to the show. Very excited to have him here today. Let's get into the interview. All right. Well, hello, John. How are you doing today?
I'm doing real good, Sean. How's it going?
I'm doing great. I am really happy. Thank you for coming on and talking with me today. I really appreciate it.
That's fine. I've actually done live radio in the past, so I'm really kind of used to doing this kind of stuff.
Oh, really?
Yeah, I've done a couple of live radio shows through the years, and it's interesting doing that. It's a form of advertising, but it does help get a lot of information out to the public who wouldn't otherwise have access to the things that we really deal with day in and day out.
Well, that's awesome. Well, hey, for anybody that's listening, would you care just to share a little bit about yourself, your roles and your experience?
Well, I've been a technician over 40 years, so you can tell by the gray hair and the lack of hair. I started out in the dealer world. I went from Ford dealer to a GM dealer about 82, and about 88, I finally moved into the aftermarket, the independent world, because I wanted to be self-employed, and I knew I needed to get a lot of training, a lot of experience before I opened my own doors. Well, that finally started to happen in 93, and then by 1998, I had my own shop. So that was a goal that we worked our way through. And my wife and I ran it all by ourselves. I turned every bolt. I've never had employees. I didn't want to be somebody else's boss. I wanted to be a technician, but working for somebody else wasn't working. And I'm sure there's a lot of technicians out there who've been in the same condition. Now, being a shop owner isn't for everybody. To do both, you're working really hard. You're putting in a lot of hours. And of course, with the technology advancing the way it was, you can imagine here I am trying to work eye level with the dealerships. And then I've got other shops around me who have more employees, and they're kind of dominating the market as far as how much work that they could turn and what they could price it at. At one point, I had 17 scan tools in my arsenal, 11 of which were OE. in
Wow.
order to do what I was doing. So I kind of carved myself a niche in that respect, and I was active on the International Automotive Technicians Network. So a lot of people are going to be familiar with the IATN, and I always made my opinions known, whether they were appreciated or not. It was going to be an individual taste, but I would put them out there. And one day I'm at work, just a casual day, hustling, not busy enough to really make all the money we want, but busy enough that it was hard to do much of anything else. And the phone rings, and it's Chris Chesney from CTI. And he asked me if I would be interested in trying to teach a class. Well, I'm willing to try anything. And, you know, I can tell you firsthand, it hasn't all been good. You know, there were some times that I wish I could have done a better job than we did. But like everything else, you try to improve, you study, you work at it. And now I've actually been teaching for 14 years for CTI.
Awesome.
And I pinch myself when I think about how long it's been that I've actually been doing these classes. And I've actually semi-retired from fixing cars. I've had some spinal issues. I had to have some surgery, and the physical side really beats me up these days. But I still have the technology side. I actually, when I was at the GM dealer after I'd left the Ford dealer, GM had computers on all their cars. Not all their trucks necessarily, but all the cars had computers by then. They didn't pay us anything for diagnostics. They just thought that we were supposed to know what was wrong with the car. Well, of course we didn't. It was just the same then as it is now. You have to spend the time to figure the cars out. So again, like I say, I was struggling to make money. And of course, that's Western Pennsylvania. The steel mills are all shutting down. We're going into a pretty serious recession. And I kind of decided I was going to quit working on cars. I was going to study electronics and then learn how to work on computers. Well, there's a university, it's called the Cleveland Institute of Electronics. You do it at home, and you do the courses one at a time, and you've technically got an instructor that you are filling everything out, you're studying yourself, you do the tests, you mail them in, and you get your grades, and you got somebody that you can pick up and you can talk to once in a while if you got something you don't understand, but you really teach yourself electronics. In 6 months, I actually completed the entire first year of the associate's degree in digital electronics engineering.
Wow.
With a pretty good grade point average. I got better at diagnosing cars because I knew electronics, and especially computerized electronics, at a completely different level. Now, you know, built my own oscilloscope and things like that as part of doing the classes. So, you know, the training gave me an edge that today every technician really needs to have. And you'll see that as we do some of like this podcast, and maybe if we do one or two others, I rely heavily on that education that I got 30 years ago, 35 years ago now. You know, time has really flown by.
Yeah, it's always that limitation for a lot of technicians when we get to the computer, to the board level. Well, what do we do? What's inside of there? What's going on? And it's not always included on a wiring diagram or in a description operation. So I can imagine that's invaluable doing this sort of work.
Yeah, and now we've met each other through that Facebook group that I run, and of course I'm a member of a bunch of other groups. I call it Automotive Technicians in Training because, first of all, you never stop learning. I've been doing this more than 40 years now, and walking up to something I've never seen before is normal. I can remember being a technician at the GM dealership, and one time, had something that I didn't know what was going on with it. I had to get the books out, and I'll remember the service manager is coming by, and he's like, "I can't pay you to learn how to work on that car. You're a master technician. You're supposed to know that." He was wrong. He was wrong then, and it would really be wrong now for somebody to say that. So part of a diagnostic routine means that we need to be able to get a baseline on the vehicle, get the code description, the code number description, go to service information, find out how did the computer run that test, because that's what a trouble code is. It doesn't tell you what parts bad, it tells you what tests failed. Well, now you got to figure out how you can test the exact same way that the computer did. which of course is going to lead us right into the oxygen sensors, which is what we're going to be talking about today, is what exactly is an oxygen sensor? How does it work? And then once you understand that, when you have a trouble code for one, well, now you can figure out how to manipulate what's in front of you and prove, why did the computer decide that it thinks that that sensor is bad? Is it really bad, or is something else actually going on? And this all builds. And you're going to see, we're going to just do the same routines all over again. It's just the actual tests will be different.
Yeah. Just really about, understanding how each individual component or system works is so important, taking that time. And so the reason I brought you on here today is to talk about oxygen sensors, specifically the narrow band sensor. Just to make it clear to everybody, there's also wide band sensors, which is a whole other animal. Maybe we can tackle that another time, but we're going to stick with the narrow band. And this is a sensor where, when I was a tech for Firestone, I thought I understood how they work. I thought, a very common misconception is that it detects the amount of oxygen in the exhaust. Well, it's an oxygen sensor. Of course, that's what it does. And I knew the voltage levels, and I did a pretty good job of diagnosing them and doing it in the field. And okay, this sensor's bad, I'll put it in. It wasn't until, 3-4 years ago, and I actually started doing some reading and realized I didn't really understand how these things work, and they're far more nuanced than I ever thought. So it's actually a pretty complex little sensor and a unique sensor because it makes its own voltage. But I thought getting somebody on here who really understands their function, we can walk everybody through how one of these sensors actually works. And like you said, what is the computer actually looking for? What's happening with an O2 sensor? So
yeah, and I'm going to give you a little history. One of the technicians in Arizona, a member of the IATN, John Riggle, brilliant technician. One day he was so frustrated trying to figure out how an O2 sensor works, he built himself a test bench with a pipe, and he was able to plumb in the different gases, CO2. He could hook it up to a car and just have exhaust gas going through, and then add or subtract as he wanted to, trying to prove what the sensor actually does. And anybody who's a member of the IA10, if you sponsor it, you can search tomato sensor, because the overwhelming decision from John's research was, whatever the thing is, it ain't an oxygen sensor. It doesn't sense oxygen. So let's just call it a tomato sensor, because it makes just as much sense. And so anybody who wants to go through that, you'll get some very entertaining posts. And of course, in any setting, we are pretty defensive about what we learn and what we know. Our trade has a habit of bullying each other. And, we've got to have that ego that supports us. You're not going to tell me how that works. We have to admit to ourselves that we don't know something to sit down and try to learn it. And I learned how an O2 sensor works exactly as you described. I'm like, I've done this for 20 years now. What are you telling me that it doesn't work that way? Well, it doesn't work that way. And we've all been there. We've all had to go through that, moment. And hopefully we can help share some of these little tricks. But by now, everybody who's watching the podcast knows, I'm telling you, an oxygen sensor does not sense oxygen. It really doesn't. Now, I've got a reference, and I'm sure everybody knows somebody that wears hearing aids. I got some hearing loss after all my years. I wear hearing aids. And one of the interesting things about a hearing aid, I got to replace the batteries all the time. They come with that little piece of tape on them. You first look at that little piece of tape, you think, well, that's so you can hold on to it. No, there's 3 little holes under there. And when you take that piece of tape off, you expose that battery to atmosphere. The battery absorbs oxygen from the atmosphere, and that's what makes it turn on.
Interesting.
Gee, what did I just describe? An O2 sensor.
Right.
Because where does it get its oxygen in order to make it turn on? From the atmosphere, not from the exhaust. So here we are, and I'm going to describe this. And if you join my Facebook page, I've got a couple threads on this. And by the way, we're going to be doing live classes online. Tim Iezzi and I are teamed up through CarQuest Technical Institute, CTI, and we're going to be doing the Scan Tool Academy classes, the series. So some of the things that I'm going to be describing now are directly related to, and in some cases you could say from, those training classes. So when you get a chance, you're going to see some links so that you can go to CTI Online. That'll be CTIONLINE, one word, you can Google it, and you'll be able to follow the links, find them to the virtual training classes. People who are members of the CTI already can join in automatically. You've actually got credits that you can use to attend the classes. And with the coming weeks, people who aren't members of our training regions are going to have the ability to join in and then pick and choose whatever classes they want to attend. So over the next couple months, I'm giving you a pretty good teaser right now, but believe me, there's way more to it than what we're going to cover in a 1-hour seminar.
Yeah, and I'm going to include all the links in the show notes. So if anybody's interested, you can just go in there, click on it, and look into this. But I strongly encourage everybody listening, if you want more information on this sort of thing, make sure to check this out because they've got great classes and great instructors. And
yeah, we've got 40-some instructors, and I can tell you that there's over 100 classes that I can present. So that's a lot of material that's available. And there's other sources of information and training. There is no bad training out there. Get as much as you can because, let's face it, you never stop learning in this career. Okay, so let's talk about the tomato sensor.
All right.
Because that's a fair name for it because, again, it does not sense oxygen. What actually goes on inside the exhaust stream where the oxygen sensor is at? You have in your exhaust gases, you got CO2, you got water vapor. But then you've also got oxygen that wasn't used in the combustion process. You're going to have unburned fuel, hydrocarbons, and you're going to have carbon monoxide. So inside the exhaust, that oxygen sensor, that ceramic device, actually acts like a little catalytic converter. And when combustibles, hydrocarbon or carbon monoxide, come in contact with it, if there is oxygen in the exhaust, it really acts like a little catalytic converter. It catalyzes it, and it doesn't do anything. End of story right there. Now, as greater levels of combustibles come into contact with the sensor, you end up not having enough oxygen in the exhaust to deal with it. The sensor, by design, actually absorbs oxygen from the atmosphere. Sometimes it does it right through the insulation of the wire. Sometimes you'll see a little tiny hole in the body of above the ceramic portion of the sensor. That's where it gets its reference oxygen. Under heat and into the properties of the sensor, it takes the oxygen molecules, breaks them apart into ions. These oxygen ions can actually migrate through the body of the sensor and catalyze any combustibles that come into contact with the ceramic portion of the sensor inside the exhaust. As those oxygen ions move through the sensor, that creates the voltage. So that's why when you're looking at that O2 sensor voltage, if you don't need ambient oxygen, you see 0 volts or close to it. As you need more and more ambient oxygen to catalyze the combustibles that come into contact with the sensor, you keep seeing a higher and higher voltage. Now, traditionally, we look at that bias voltage level, that 0.450 volts, about a half of a volt, and we say that that is our switching point. One of the interesting things about our narrowband sensor is that if you are leaner than stoichiometric air-fuel ratio, you get a low voltage. Now, a narrowband sensor isn't linear, and in some training information, they would tell you that once you go lean, the sensor switches low, the voltage goes down, and if you go leaner, you cannot really see how lean you went. And there is some truth to that. Now, the voltage will go down to 0.3, 0.2, and if you go leaner, it will go lower, but it's not linear. You can't look at it and say, though, that was X% leaner. So you just have to get used to that it has its switch point, and you go lean, you go low, you go rich, you go high. You get richer, you can get higher, but you can't look at it and say that was how much richer. So just be comfortable with that part of how the sensor actually works. So is that making sense so far?
Yeah, definitely. So, we could see 0.7 or 0.8 volts. We can't give that an air fuel ratio number exactly.
Correct.
We just know that's on the rich side of the scale, or if it's below.
And it did get richer, but yeah, you don't use that for any kind of a reference.
Sure. And again, that's narrowband sensors. Talking wideband sensors, things will change. But yeah, with a narrowband sensor, it's just sort of it's like a switch. I think is a good way to almost describe it. Is we're switching. Is it lean? Is it rich? Is it right there at stoic?
Yep. And of course, stoic, lambda, equivalency ratio. Those are phrases that everybody's got to get comfortable with when it comes to dealing with today's cars, because one of the myths that are out there, and you saw this in some of the threads that I put on that Facebook group. One of the questions I asked was, what air fuel ratio does the engine control module try to control the engine at? And we were taught what?
14.7 to 1.
And it's a myth. And it's like, it's what? And, I actually did the field trim class at the one junior college, more eastern Pennsylvania. And their textbooks still teach that. And the one instructor was just beside himself that I would say that. Oh, that's wrong. There's no way. It controls it to 14.7. Pure gasoline, the stoichiometric air fuel ratio would be 14.65, so 14.7. We're going to call that close enough. Do we get pure gasoline out of the pumps?
Not quite.
Yeah, what do we get? Careful, got to be PC here. So what do we get? E10?
Yeah.
E15? I've seen E20, E25, who knows what it is. It's something more than 50. And the stoichiometric air fuel ratio for whatever fuel's in the tank is different for every one of them. So the computer literally needs to figure out what stoichiometric ratio for what's in the tank and then go and control the car. And we don't have alcohol sensors on the cars anymore. We did for a couple of years, but then they figured out how to do it with the fuel trim and how the car can actually, at a certain point in time, relearn the alcohol concentration after you had a refueling event. And again, remember, I'm giving you pieces here. We need to actually do the entire classes for everybody to have a reference for how this truly works. There's a lot more to it than what everybody thought about.
Yeah, no kidding. So going back to, the sensor, and we're saying that there's a catalytic reaction, happening inside the exhaust on the surface of the oxygen sensor, that we have combustible gases, hydrocarbons, carbon monoxide, reacting with oxygen on the surface of that oxygen sensor. So would you say there has to be those combustible gases there in the first place for the O2 sensor to do anything?
Absolutely. Without the combustibles, it doesn't do anything. And that was one of the things that when I talk about John Riggle and he was trying to test it, because you'd have people say, well, partial pressure or this or concentration. Well, he was changing all different kinds of oxygen and carbon dioxide. And the sensor does nothing. It needs combustibles to start to produce a voltage. And that's one of the biggest things about it that you look at and say, well, wait a minute, it's not oxygen. It's
right.
Reacting to combustibles. And one of the little things that I did on that Facebook group is I put a little question up. I said, picture you've got an O2 sensor in an exhaust stream. So it's putting out a given voltage. And there's a certain amount of oxygen making it past the sensor. If I put a little port into that exhaust stream above that sensor and I start adding propane, fuel, what would you expect the sensor to do? So I'm not changing the oxygen concentration. It's staying fixed, but I'm going to add a combustible. What do you think the sensor is going to do?
I'd expect the voltage to rise.
And that's exactly what it does. So did it react to oxygen or did it react to the fuel?
Yeah, it's the fuel, the combustible materials, and that was a big eye opener for me, because why do we call it an oxygen sensor if that's how it's actually working? But I mean, that really changes your thought process on what this sensor's doing, and how it's reacting to different problems, even in the engine. I know misfires can react differently.
You'll see a lot of different trains of thought, and some of the stuff works, and sometimes you'll get a car and it doesn't work. When you have a misfire, you get a lot more oxygen into the exhaust. Now the question is, did you get fuel with it? Because sometimes we're going to shut an injector off and you're not getting fuel. Now, meanwhile, you've got other cylinders that are providing fuel, and the computer's looking at that O2 sensor output, and it's going to try to move the fuel trims to make that sensor voltage move, which means those are all getting too much fuel because you got all this extra oxygen. One of the nightmares is if you're getting raw fuel into the exhaust from the misfire, and that long chain hydrocarbon comes in contact with that sensor, it doesn't matter how much oxygen's in the exhaust. The sensor can't handle it. And it's going to use ambient oxygen to help catalyze that fuel, which means the voltage is going up, not down. It thinks it's rich, not lean, but it's real erratic. You'll get O2 sensors that'll be moving really rapidly in a misfire. And I'll go back into the 90s. You know, we're IATN people. We're teaching each other. We're figuring this stuff out because nobody's ever taught this. And we're putting an oscilloscope on the O2 sensor because the scan tools weren't fast enough to show us the data. And we get a car that has a misfire, and you would see the hashing on that O2 sensor from the misfire. So I could actually, in the 90s, I could take a V8 engine, look at both O2 sensors on the scope, and I could tell which side the misfire was on because of the noise that we would get on the O2 sensor. By the way, has anybody tried to troubleshoot a P219A trouble code for a cylinder air-fuel ratio imbalance? That's fun because we got cars out there that don't tell you whether the cylinder is richer or leaner. It doesn't tell you which cylinder it is. And guess what? We can use the oscilloscope, put an overlay off of the O2 sensor waveform, synchronized to a particular cylinder on the engine, and figure out which cylinder is richer or leaner by the noise.
Man, I love scopes. They're so cool.
What did we do without them before we had these toys? I'll get an older car that, you know, I can remember how we figured cars out in the 80s. And let's face it, we saw the same things a lot. There were a lot of stuff that was new to us, and it would always drive us crazy. But eventually we got to the point we kept seeing the same things. So the diagnostics wasn't as involved as it is today. It still needed to be done right. And it needed more, you know, discipline than what we were doing, but nobody was paying for it. So who was going to spend the time? But now I get one of the older cars in here, and I'm going to hook up my toys. I'm going to hook up my picoscope, and whatever my decision is as far as my diagnostic routine is going to be, when I walk right into the same answer that we would have gotten through other routines years ago, and I'll just like shake my head. How the heck did we do this without these tools? You know, There was a lot of guesswork, experienced guesswork, but it really wasn't as disciplined as what it needs to be today.
Yeah, you reach a certain point where, like you say, you got to make a call on something, and maybe you're 90% sure. But yeah, with that scope or with some of these other tools, that can help us get that 99.9% sure, you know.
Yeah, you're always going to have that one car that no matter how much you studied and practiced, it's like, what is this thing doing? And you'll struggle to figure out a way to manipulate something to give you a way to look at it from a different angle. And those cars are out there. Somebody else has probably fought it at some point in time. And, you know, probably one of the biggest mistakes technicians make is, you know, hey, I'm going to jump onto Identifix and go find the answer. And let's say they find the answer. What did they really learn? Did they actually learn how to diagnose the next one? Or did they just, okay, I'm going to change that part again? And what if that doesn't fix it? And now they didn't practice the diagnostics. Now you can see that just getting that silver bullet answer is actually a trap, because you're not practicing hooking the tool up, using the scope, developing a diagnostic game plan. All real critical points that we should be rehearsing. Every single simple repair is an opportunity to practice for when we get that one that's going to Teach us something we didn't really want to know that day.
Yeah, exactly. Yeah, you get your process down, you know your test, you know what to see. Yeah, and you do that consistently. Then when you have that problem car, that issue with whatever, it stands out. Like, oh, okay, well this now is simple because I've done my process so many
Yeah,
times.
and you just keyed it right there. You don't even recognize when you approach that car that would have driven you nuts, because you're so disciplined, you got your routine down pat, and you just go right through it. You go straight to the answer, you fix it, and you move on. And meanwhile, it was a legitimate trap car, but your process carries you through. And this is built over years. It's built learning the tools. It's built getting beat up. Those cars are out there. We all get them. I still get beat up from time to time. It's like, oh my God, I should have figured this out a long time ago. But then you step back and you say, okay, maybe you got to tweak your routine a little bit. Maybe it wasn't quite as good as you needed to. And next one, okay, then you go through and you do an easy one. You're like, all right, I didn't lose it. It was just that one was that hard. I had a guy watch me troubleshoot power windows yesterday, and he was just in his jaws because in less than 10 minutes, I've got a solution. We're going for a repair, and he was like, and it's fun when you can work at that level. And that's the thing. You should get to enjoy what you're doing as an automotive technician. Yeah, there's going to be the rough ones, but you really should be able to get some of those done and say, that was fun.
Yeah, and I feel like most of the people that are listening to this podcast, they want to get better with these diagnostic skills, but it's the part of automotive repair that a lot of us really enjoy. That problem solving, the challenge, the puzzle, whatever you want to call it. It's different than just hanging parts and fixing the car. There's a satisfaction in that too. But man, solving a problem, working through, being able to call, okay, this is what's wrong. This is what's going to fix it. That's a whole different type of satisfaction in your job. And that's why I'm into this. That's why I do it. It is fun when it goes right. But yeah, there's those cars. They are going to humble you, no matter who you are, and you
absolutely
gotta be ready for that.
Yeah, we all get them. They're out there, and then sometimes you have to walk away. I had one that was actually really difficult to figure out not that long ago, that I probably had an hour and a half, maybe 2 hours in, really examining what was going on. And then it's like, all right, go home, get back to the house, call it a night. Walked in the next morning, and then overnight you relax, the wheels start to turn a little bit. Walked in the next morning, had a game plan, went straight at the answer. But I probably would have figured it out the night before, but who knows how many hours I would have actually spent. And that's not fun. You got to have that other car that you can go to, that you can walk away. When I was running my shop, I didn't actually have one of my favorite devices. Before I had my shop, I did a lot of alignments. A lot of people, everyone always today, they think of me for a lot of high-tech stuff, but I fixed cars for 40 years. I've got thousands of alignments under my belt. And back in the day, I would be working. I'd have a car that I was having trouble figuring out. Hey, give me a couple alignments. And I'd knock a couple alignments out, get that gravy work done. Yeah, maybe get some front-end parts and stuff like that. Turn my hours, go back to the nightmare car and now I don't have that try to beat the clock in my mind, adding the extra layer of pressure. Because I can tell you from my dealership days, I was taught incorrectly how to diagnose. Because again, they didn't pay us anything for doing diagnostics. And it's like, well, don't you know what's wrong?
The computer tells you, right?
Yeah, the computer tells you. Computer says things like, you get ready to hit that button. It says, are you sure? Well, I was a moment ago before you asked me that. Now I'm not sure. So I don't know. What do you think? Did we cover the O2 sensor well enough?
The last thing that I was going to ask you about was we use the O2 sensors, obviously, in the front of the converter, and fuel trims are involved with that, but we're also using them downstream of the converter, the catalytic converter, to monitor catalytic converter performance. Can you speak to that at all? Because it's the same sensor, essentially. It's going to do the same thing, but we've got some, different exhaust gases on the other side of that converter.
Yeah.
What's happening back there?
Yeah, well, the converter doing its job, it needed hydrocarbons, it needed oxygen. It's going to have oxides of nitrogen coming down, and we'll do oxides of nitrogen some other day. Let's just talk hydrocarbons and carbon monoxide at this point in time. Keep in mind, like I say, NOx is part of the equation, and in today's converters, it's actually, we used to have like a dual bed converter, and they would tell us that the front of the converter would control carbon monoxide, or the front of the converter controlled NOx, the back of the controller would control the carbon monoxide and hydrocarbon. Today, those reactions are taking place side by side right through the entire catalytic converter. Now, I've already described that what the O2 sensor does is not sense oxygen. It reacts to fuel and whether it needs ambient oxygen in order to catalyze those combustibles come into contact with it. When everything is working perfect the way it's supposed to, you're driving down the highway, front O2 sensor swinging up and down, you got a good switch rate on it. Rear O2 sensor kind of just settles down and runs in a fairly steady voltage. Does anybody right now, you're watching this, have an idea roughly what is that voltage you typically see? Does it have a specific range? And what do you think, Sean? Do you got a number in your mind?
Yeah, if you're at a steady RPM, I would say somewhere around 0.6 of a volt.
0.6 volts. And again, we're getting back to that. You can't look at it and say that this is very rich or just barely rich, but it's above the midpoint. It's showing you a voltage, so we actually are to the rich side. Well, think about rich. Rich means you've got a combustible there, and you've got very little to no oxygen, correct?
Yeah.
If you would take a gas analyzer and you put the probe up the tailpipe, as the converter gets hot, you're in closed loop, things get to be more stable, you actually see the O2 sensor or the oxygen content of the exhaust, I got to say that correctly, the oxygen content of the exhaust approaches zero. It basically starts to disappear. And here's that O2 sensor floating just above the midpoint. So what's making it all the way through the catalytic converter? Some type of combustible. You'll look at hydrocarbons. You'll see those go to zero. And then when you're looking, there's a little bit of carbon monoxide that actually makes it all the way through the catalytic converter. Well, carbon monoxide's a bad gas, isn't it? It's poisonous. But a little bit of carbon monoxide can be tolerated as far as an exhaust gas. And it really comes back to we need a little bit of CO to make it all the way through the catalytic converter to control NOx. So again, we'll talk about NOx some other day, but that's what's actually going on when you see that sensor floating just the way it is. And the downstream sensor, in fact, has more authority than the upstream sensor in certain circumstances, because they're going to use that downstream sensor to make sure that that carbon monoxide is available to control those oxides of nitrogen.
So as far as fuel trims go, it has an input to them.
It has a significant input. And I will leave that, of course. I want technicians to sign up for the classes we teach. You will get a very great demonstration on just how much authority the downstream sensor actually has in some of our classes, and a very particular case study, which is like, oh my goodness, you'd be surprised what the downstream sensor is capable of.
Yeah, I'll tell you what, that is a great explanation. Both sides, that O2 sensor on both sides of the cat, that's awesome. And yeah, I'm really glad you come on and help me out with that. So, and it's good. This is a good showcase for everybody listening. Go attend these classes, because you can get this type of information, and where else are you going to figure this out unless you build your own bench test for exhaust and sensors? And not everybody's got the time and patience for stuff like that. So it's why going to training is so worth it to get information like this.
We actually have a catalytic converter class. It's a 4-hour class. The scan tool class that Tim Iezzi and I are going to be doing, we're going to cover a lot of the fundamentals. And, a lot of technicians, there's a lot of different levels. Sometimes we can get into a class, you might think, wow, this is below me. And then if you hang in there long enough, all of a sudden you start finding out, hey, we get into stuff that you weren't ready for. So there's always going to be a potential level for review. We've got a lot of entry-level technicians that we could get into some material and we can go over their heads so fast, that doesn't do them any good either. So you really want to look down through the list of classes that are available. We are bringing, I believe, it's over 100 seminars of about 10 to 12 of our regular classes with different instructors are going to be hitting, the internet starting next week, starting Monday night. So you want to get onto CTI online, the virtual training. You'll see a black block for training. When you go mouse over that, you'll see the virtual training, and from there you can actually open up and watch some videos that'll show you how to navigate the virtual training site, and then pick and choose the classes that you want to attend. Sky's the limit. Adam Roberts has been doing our Picoscope classes. Have you been using a Picoscope, Sean, or are you using something else?
Yeah, I have a Pico, and then I have a U-scope as well for quick stuff.
I've done some of our regular scope classes that I do hands-on sessions for, and I'll tell you what, you want to talk about trying to keep on top of things with me having like 4 or 5 different groups going and different scopes and trying to make sure that I know the buttonology on all these different tools. It can be a real challenge sometimes.
Yeah, no kidding. Well, that's awesome. Unless you have anything else to add, I'd just like to give you a huge thank you for coming on with me today and spending some of your time here.
Again, I'll get back to the Facebook group. It's Automotive Technicians in Training. So just like it sounds, you can search it. We got almost 1,600 members on that group right now. There's a certain same ones that are active, but I can see, on the other information, how often it's being accessed, which is quite a bit. And you can get hold of me through Messenger if you're joined into that group. If you got a car that's beating you up, I am not going to tell you what's wrong with it. Probably don't know what's wrong with it, but I can tell you how to figure it out. And I think that's the magic of what everybody really needs. If you buy yourself a Picoscope and you're struggling with the buttonology, we can do groups, through Facebook. Obviously, we've got the regular CTI classes where we can give you a lot more information. I attended the classes that Adam was doing earlier this summer with learning how to do the math channels. I had dabbled with it, but I had never played with it to the level that Adam has. And it's like seeing this much capability at our fingertips. The Picoscope is a tool we will never outgrow. There's other tools. You buy a Vantage. Hey, it's a graphing multimeter, but it works like a scope. It has built-in testing, routines for you. It can take your levels from little experience up to a point that you will outgrow that tool. That's okay. A lot of technicians have moved on to a Picoscope, and some of them sell it. They're graphing multimeter. Some of them turn around. They love that Vantage so much they still have both tools running. And everybody, you're free to pick and choose how you want to progress, but put a plan together that gets yourself adding pressure waveforms into your routine, adding current probes to your scope usage. You'll find that it will start getting easier. We can't make it easy, but we can make it easier.
Okay, I hope everybody really enjoyed that. I think that's a pretty thorough explanation of how these narrowband sensors work. One more big thank you to John for coming on the show today. Just awesome stuff. So everybody that's listening, make sure to check the show notes for the links that we've mentioned, the CTI online, the training sessions. Just great stuff that is going to boost your career, boost your diagnostic skills. I can't say enough about it. Other than that, let's get out there and start fixing the world one car at a time.